Here. Welcome guys to another episode of Legacy Code Hero. Finally I have a driver working. I'm very excited about that. So let's go and look at the code this time so that you have an idea of how much effort I had to go through. And you're gonna find out that there is not that much code, and that makes me very happy. So let's go to gamepad. Core pre-initialization, subrouting, let's go there. So it turns out that you don't need to do so much as in the original code. All that you need to call is hot plugging, which we have seen a couple of times. I'm not going to show it all over again. And after that, you're pretty much set up. After that, you're pretty much set up. You have to store the private data. Essentially in here I'm storing the information about the gamepad and the keyboard devices, and that's pretty much it, so that I can use that whenever I'm reading events from the device. So the driver, it's simply a translation layer between the Linux kernel input events and the X server. The X server doesn't know what a gamepad is. All it knows are key codes. So what we are doing is simply translating keyboard events. No, sorry, not keyboard events. We are sending key codes based on the buttons and D-pad actions that the user takes. The Linux kernel is going to tell us what button was pressed, and essentially we generate a key code based on that. That's all that there is to it in a nutshell. So let's continue to go to the control procedure. And for the keyword, I believe we saw this briefly. If not, don't worry. The one for the gamepad looks pretty much the same, because we need a slaved keyboard device to make this work. We need to call init keyboard device struct. We just pass the device keyword. This is the input argument that this function anyway has, so there's not that much work to do in terms of writing code. We just verify if it returns a success or an error. If it's okay, we are good with the device initialization. Later on, it's going to try to enable the keyboard device. We just set the device is on. If it's off, we just say it's false. And if it's closed, we do exactly the same. And if there is an error, we also set it off. And that's all that there is to it for the keyboard device. This is less code than the original implementation. So let's look at the gamepad one, which is this one right here. All that we have to do during device initialization is call gamepad device open. We already have the path, which is what I showed you before, def input in dep event. Yeah, right. The dep input in the name of the entire name of the device. We have seen it a couple times. I'm just gonna type it here really quickly. So we have dep input event. Sorry, event some number. That's the path of the device. We open it, and that's all that we do, and then we call the device initialization. We have a couple things to do. After the device is open, we have to define some evaluators. Without them, the X server is going to ignore the key events that we send. Okay, so this is the one thing that is pretty much the same in terms of what the original implementation did for the joystick device. So pretty much I'm following that here, because without them it's not gonna work. Other than that, here I'm just checking the number of buttons, the number of access through IO control calls. If you want to know more about it, there is some really interesting documentation about gamepads in the Linux kernel. I don't know if you guys are interested about that, but I essentially followed the docs and followed the Linux kernel source code and the headers. So here I'm just counting buttons and access by doing test bits. If the bits it's set, that means that's an X, that it's actually in the device. If it's not, well, that's not. So after knowing the number of buttons and axes, we set the labels. It's just a string. Make Atom is going to store it in the X server, and then for the first time we call init evaluator class device struct. We pass in the gamepad device and some number that tells it we have these many evaluators. In this case, it's just 4 evaluators. We need 2 for the screen and 2 for the gamepad axis that are going to be enabled, just the D-pad. And this is exactly how the joystick implementation looks. I'm not doing anything different here. And then we initialize the axis by passing these known properties, and this is for the screen. Here we're saying this is how width the screen is, and that's anything beyond this limit between 0 and whatever the width is, it's going to be wrong. So we are just telling that information based on the data that the server gives us. This screen info is a global data that we have access to. It's not something that I define. And also for the height, and then we do this for the axis. Even though I'm not converting these values, these are the ranges for analog sticks. And the D-pad, if it's reported as an analog thing, it's gonna be in this same range. So I'm using these values, even though the code that I wrote is not even using these. It just sets to 0 and 1, which is whether it's key press or not, whether it has been pressed or released, and that's pretty much it. And after that, I just store the number of axes, the number of buttons, the open, the read, and the close functions, and you can guess what these pretty much do. But of importance, I think that we should look at the read function. We just calls read. I pass in the file descriptor and just reads the bytes. We're not gonna look into that. If you're interested, you can look at the code from GitHub. And then it says, it checks, actually this is not done in the original implementation, whether the device lost synchronization. This is something that the developers mentioned for lib input, but they don't do it for the joystick. So there's no code that handles that. I did that. So if it lost connection, it has to drop all the events until the next scene report. You can find all that information also in the Linux kernel documentation. So I'm just following the docs, just following the code, and got a driver working. And this, I believe this is the best way to learn. So finally, gamepad device read. Okay, so you already saw this function. If the read fails for some reason, right here, this is the function. If there's no read function, it's going to return. It's going to disable the device. Otherwise, it's going to read, and if there's an error, it's going to disable the device. And probably, yeah, go to disable. Essentially, it's going to jump. I won't have to worry. So this return right here, it's doing essentially nothing. I could remove it later. It's not necessary. The go-to does it. Now here it's the magic. Let's say I initialize the key code to 0, and I know from this event fdef key codes that the up key is 111, and the left and so on, down and right. These are the key codes for the arrows. And so if the axis was set, for example, the x-axis for the D-pad is set, it just checks the key codes, and then it does the right things, whether it's left or right. It's fairly simple. And the same, if the y-axis was set, depending on the value, then it knows whether the user pressed up or down and sets the key code accordingly. Fairly simple code. Similarly, for the buttons, button north, west, south, and east, most gamepads have these 4 buttons. If they don't, well, don't worry about it. These are not going to be triggered, but if they have to, one of them probably is going to be south and north. So it's okay to have the code here even the buttons are not present in the device. The Linux kernel will send the right code right here. We're just handling it. And it sets the key codes accordingly. These are macros that I define for the key code WASD. We can use any other ones. It's up to us. If there are no key codes, sometimes the Linux kernel won't give us anything that we want to match here. So the key code is going to be 0 and we just return and we say absolutely nothing to the X server. Otherwise, then we post a keyboard event. And now you will think that this will be easy. It's not. There's a lot of code going in there. It's incredible. I've spent hours digging through these calls, trying to figure out why the driver was not working. It was a lot of work, guys. So this is not, you may think this is easy, but it's not. It's definitely a lot of reading, a lot of time. And sure, you can use AI. Maybe it will give you something that works, maybe it doesn't, but I don't care about that. I just want to learn. And maybe this is why you're here too. Okay, so, and that's pretty much it, guys. That's pretty much it. That's everything that's going on. There's nothing else. Of course, the driver right now has a few bugs. I will have to use GDB to fix it, but it works, let's say 99% of the time. And when I say that is that sometimes when I press the up key or the left key, it stays like, it doesn't stop. It keeps repeating itself. And I pretty much know what the problem is. I'll just have to use GDB to check what it is and then fix it. It shouldn't take too long. Well, yeah. Well, I just hope that these kind of series help you dive into whatever code that you're interested in. It doesn't have to be X server, and you try it. As you can see, I have a lot of comments in the code. I hate comments. I hate writing all that stuff. But hey, this is not documented. If I look at this code a year from now, I'm not gonna remember much, and these notes are going to help me keep up if I ever want to come back to this. So this is what I've been trying to do. This doesn't mean that it's gonna be like the last episode. There's still plenty of things to do, but I think I'm gonna stop it for today. Thank you guys for watching the series. If you have any comments, you can find me on LinkedIn and you can tell me what you think, and that will be great. So guys, take care. Thank you for watching. Thank you for following. Looking forward to be sharing more stuff that you might be interested in the near future. Until the next time, guys.